Hello everyone, in this video I'm going to talk about my microwave electronics course project, which is designing a two-stage amplifier. And the first stage has to be a LNA and the second stage has to be a high IP3 amplifier. And these are specifications. Our design has to meet all of these. Additional of that, our gain has to be as much as possible and our noise has to be as small as possible. And this is our first schematic. You can see the first stage here and the second stage here. I used the transistors from the Cree library and I chose the DC operating points and the widths of the transistor to meet our specifications, and I tried to use as much as transmission line I can. I only used resistive elements, capacitors and inductors in the stability network and also for DC block and DC feed. And this is the input matching network of the first stage, and this is the stability network of the first stage, and this is the output matching network. It's also the input matching network of the second stage. I tried to combine them, and this is the stability network of the second stage. I put it in the input side of the second stage since it's a power amplifier and high IP3 amplifier, and this is the output matching network. And here is our first results. Stability factor is greater than 1, which means it is unconditionally stable. And this is our input return loss, it is greater than 7. And this is our output return loss, it is greater than 15. And this is our gain. In the center frequency, it is almost 27 decibels, and the gain variation is less than 0.5. And this is our noise figure in the whole range. In our band, it is almost equal to 3 decibels. I will show the close lookup later. And this is our IP3. It shows that how flat our gain is, and it meets the criteria as I said before. And this is our advanced schematic. All the components are changed from Cree library to design the layout. This looks horrifying, but it is basically the schematic before. And additional of that, the banding components for transmission line added, DC block and DC feed components are changed with capacitors, inductors, and so on. So you can see the input matching network here, and you can see the banding components here and the splitted transmission lines here. As you can see, these are DC feed inductor. All, as I said, for all components are changed with Cree library elements, and also step elements are added and T elements are added, as you can see here, to combine the branches. And this is the output matching network of the LNA and input matching network of the second stage with the stability networks. For parallel elements, I designed a square-like design in here, and it is the continuation of the input matching network of the second stage. As you can see, the transmission lines and the banding component steps here. Also, I used bridges for the combining two T elements. And this is the output matching network of the second stage. You can see the again bandings and transmission lines here. And this is our layout. As you can see here, I try to minimize the area as much as possible, and you can see here why I added banding components. I added them to minimize the area and make my design as close to a square. And this is our second results. After changing the components, stability factor increased significantly. It is unconditionally stable, it is good, but it decreased the gain. I will show you later. And now our stability factor is close to 15. And this is our input return loss. It is greater than 7, but it's not as flat as before. And this is our output return loss. Again, it is greater than 15, but the value at the center frequency decreased. And this is our gain. Maximum gain variation is increased a little bit, but the maximum and minimum value is still close to 1, and as I said before, gain decreased because of the changing the components, so now it is close to 21 decibels in the center. I chose my limit as 20 dB, so it is greater than that, so it is good. And this is the noise figure. It's in the center, it is almost 3.5 decibels. The thing is here, our transistor is not suitable for LNA, as I think, but there isn't any other transistor that I can use for LNA, and the minimum noises for one stage is close to 3.5, so it's only added the 1 decibels to the minimum point, so it's fine. And you can see the IP3 here. The maximum value is increased, as you can see here. Before it was 26, now it's 40. And you can see our final exported layout here. And this is it. This is my design for the microwave electronics course project. And thank you for watching.